Okay, welcome. Let's have a look at some different types of functions. Function question that might require us to use our GDC. Now, the reason this is going to be a GDC question is because it's a function which we probably don't really have a good idea of what that looks like. Not intuitively. We could piece together some bits of it, but we don't really have a good, clear idea about what it might look like. So, first thing we need to do is we need to sketch this graph. And obviously within a sketch we're looking to mark as many interesting points as we can. We're not looking to plot it, we are looking to just sketch it. So the first thing I'm going to do is just key it into my calculator and see what general shape we have. So let's get a new document. Don't want to save this old one, no. Let's add a graph and we're looking at, we've got a numerator and a denominator, so let's make this x squared plus 4, and that's being divided by x squared plus 1. Oof. And we've got this really interesting shape here. Okay. So what's it asking us to do? Sketch the graph of y equals fx. So we know the general shape, so let's just do 9a. We've got our axis here, and we've got this lovely symmetrical shape coming out from our calculator that makes it look something like this. Okay, what do we need to label on here? Well, probably just the y-intercepts. It doesn't appear that I have any x-intercepts. So let's just have a look at what the y-intercept is. So I didn't mean to do menu, but if I do Control and T, then I can see what's happening at 0, and it is indeed actually 4. So 0, this point is 4. And we can label that on there. So there's not really a great deal to the sketch. We would think about including a few things. We would always need to include this shape, which we've done. X and Y intercepts, which we've done. Potentially any maximum or minimums. And just to check what that might be, it looks like we've done it already, but let's just Control and Tab. It looks like we've got a maximum point. So I will, let's analyze this graph, check what that maximum point is, and it is at 0,4, the point that we've already labelled. So we've actually already done the maximum or minimum as well. The only final thing that we probably want to try and include is any asymptotes. And if I look beyond at part C, we're going to have to write down the equations of any asymptotes. So we're going to do that anyway. But worth maybe doing now. For a horizontal asymptote, we're going to look to see if there is what happens with large numbers, effectively. So we could go to the table, which was the same as my Control T, and let's just scroll down and see what happens as x gets really large. What's the function of x tending towards? Well, it looks like it's getting closer and closer to 1. So that's quite handy. I can go really, really low as well, and again it's going closer and closer to 1. So my asymptote, whether I get really big or really small, seems to tend really close towards that 1. That's what it's tending towards as it goes off infinitely large or infinitely small. So I can label on here my asymptote. I might just do it in a different colour just because I can. And there's my asymptote, which I'm going to label that asymptote as x. Ooh, actually, no. Y equals 1. Be careful. Okay. Right, now we need to work out the domain and range for our function of x. B, the domain. What x values can I put into this? Well, I went really, really large, I went really, really small, and actually it turned out that there was nothing missing, no values missing, there's no vertical asymptotes, and actually it went all the way really large and really small. So in fact it is anything on our number line, so we can say therefore the x values has got to be a member of the set of real numbers, which means it can be absolutely anything on there. Now my range is going to be an interesting one. My range are what y values that I can take on here. So I can see that it goes up as high as 4, and I know that my asymptote is going down as low as 1. So it's between 1 and 4. So my y values are between 1 and 4. It can't ever be equal to 1 because that is actually my asymptote, although it gets very close to it. But it can be equal to my 4, so I'm going to put that extra line underneath the inequality there for the range for B. Okay, making good progress. C then, find the coordinates of any points where f of x meets y equals 5. Okay, let's have a little look at that then. So we need to find another tab to put in our second equation. So where does it meet y equals 5? Well, we're looking at this on our CIM. It's a bit of a strange question because there aren't any. Hang on, I haven't even answered C. I'm rushing ahead. The equations of any asymptotes, y equals 1. I just need to copy this down. Y equals 1. For D, it doesn't. Again, a bit of a strange one, and we could double check that. I could zoom out quite a long way. I could go up 100, and I could go down -100, and you can see either way there's no point that they're crossing. I suppose I could analyze the graph and see if there is an intersection between the two. Is there an intersection between here and here, the entirety of the graph? No, it appears not. It's not allowing me to. Okay, so it doesn't meet y equals 5. Strange question. Anyway, E then is going to suppose y equals fx meets y equals k at exactly 2 points. What possible values could k have? Well, if I go back in a little bit again, so let's go back to -10 and just 10 here. If I change this one to 3, for instance, we can see that there are 2 points where it touches that graph, 2 intersections, and it's trying to give me that point of intersection I was searching for before. If I change it equally to 2, there are 2 points of intersection where it's going through both those graphs. So there's a whole range of values that k could take in order to meet exactly 2 points. So what are they? Well, they're given the symmetry of the graph, it's going to be that k is going to have to be very similar, in fact identical to my range. So k can be from 1 up to 4. And there we are.